This is not a slide-based presentation. This is a presentation in which I am actually going to be working at writing some programs. At the same time, trying to explain to you what all these arcane symbols are that are going up on the screen. They will not be anything like what you have seen before. Now, the first thing I've got to get my mouse switched on and then tell my machine that I'm here. We'll skip the introductory slide and go straight into this because we've got it on the screen at the moment. I'm going to be using a language called APL, which is one of the pretty old languages, actually. Goes back, I don't know, into the 1980s for certain. And when it was originally created, it was very popular among a number of mathematicians and very unpopular with everybody else. And the reason why it was unpopular with everybody else was nobody had a keyboard that would actually do it, and nobody had a way of demonstrating it. But the world has moved on, and now we have Unicode and easily mapped keyboards. The arcane symbols that APL relies upon become very easy to put onto the screen. And though I do have some help up here, which will tell me what some of the symbols mean if I forget and how to get them, there's a lot of value. For example, supposing I want to divide 5 by 3. Well, you think you're going to do this. Whoops. Now we have a problem as to why the thing doesn't seem to think that I'm typing anything. Oh dear. What a weird position to be in. No. Taking not a blind bit of notice of the keyboard for some reason or other. Probably because it's focused somewhere else. I'm going to actually close this down. It will tell me it doesn't like something, but anyway. And restart. Sorry about this. I thought I'd had the thing set up so that I could just plug it in and it would work, but it doesn't. Right, so that's the basic IDE. I need to customize it a little bit, so I need to load a session file. The session files are in there. That's given me a session file. It's far too small for you to look at, so we'll go to whole screen, and then we will change the font size. Now, let's see if it's going to take any notice of my keyboard. Great. 5 divided by 3. And what you expect me to do is that. Doesn't work. Let me press enter. Because what that means in APL is replicate 3 5 times. Which may or may not be useful, but it's not divide. Because, you see, in APL, when I want to divide 5 by 3, I actually tell it to divide by 3 with a perfectly good school-type division sign. Let's see if it works. Yes, fine. So that's the first thing, symbols. And incidentally, how did I remember what the division sign was on the keyboard? Because it's Control plus. Plus sign sort of looks like a division sign, doesn't it? So easy to remember. So what's next to a division sign? Well, there's multiplication. So you might say, well, what about x? Well, we need x for other reasons. So let's multiply 2 numbers together. We'll deal with 5 again and multiply it. The multiplication symbol is actually Control minus. Wow. But you see, it's right next to the control plus. So it's easy for me to remember that the division sign is next to the plus. The next is the plus sign modified, and the multiplication sign is the thing next to it. So you see, even though I don't have my keys marked with all these things, it's easy to do. There are other little bits and pieces about APL, which is quite nice. For example, what is the answer to 4 minus 10? It's not a problem, but what's the answer? Do you notice the negative sign is up? APL distinguishes between subtraction, which is a minus sign, and negative, which is a raised minus. If you forget, of course, you can always write -1 and it will convert it for you anyway, because... Okay, so that's a little bit of symbols. You have to get used to the symbols and what they mean. Now, the next thing about APL is that there is no... I've lost the word I want now. No priority between the operations. So if I write 3 times 4 plus 2, all of you are thinking there, oh, I know what the answer to that one is. It's 14. Well, you're in for a surprise. It's 18. So now the next feature of APL is its order of evaluation is strictly right to left. No priority on the multiplication sign. So that means 2 plus 4 to answer 6, multiply it by 3. So let's put aside that little bit and move on to something a little bit more interesting. Supposing you want to work out your entry to the National Lottery. So how many numbers are there in the National? How many things will you have to choose? 6, I think it is. Out of how many? I think 49, but it may not be, it doesn't matter. And APL has an interesting thing that the question mark actually says select at random, uniquely, from 49. Now, there is a little problem with that because you would like the numbers to be in correct order. Well, I actually, incidentally, of course, it's a random number generator, pseudo-random generator probably, but if I try the same thing again, I will get a different set of numbers. I need to store the answers so that now I can do something to sort the things out. So let me, being simple-minded, store assignment. Assignment is not equals. Equals is a logical operator. Assignment is an arrow, and there's a certain... It's actually control right square bracket. But if you think of it, a right square bracket is sort of like an arrow. Sort of. So now let me store an answer away in there with my question mark 49. And of course, it doesn't display the answer now because it's stored it. Want to know what it's got? Okay, well, there we are. Well, I now want to sort these. And one of the APL operators actually says rank the numbers. So Let me see if I remember what that one is. No, it's not that one. Right, okay. Those are ones which you have to remember a bit because there's no visual cluing. You have to remember where they are on the keyboard and which combination of keys. That's actually Control-Shift-3. Now, I haven't been doing APL very long, but you notice I can actually remember little things like that. So you very quickly get accustomed to your keyboard and how to use it, and you've got the thing up at the top which you can't really read, but which actually gives me information about the various different. Well, now here's an interesting thing to me. Those are functions. API is very strict that things that take arguments, which are either scalars or arrays, because there is nothing else in APL, your objects are always either scalars or arrays. The arrays may be one-dimensional, called vectors, two-dimensional, called matrices, 3, 4, 5, 6. This particular version of APL will run up to 17 dimensions if you want. A bit more about that later on. But anyway, those A contains a vector of 6 values, and I want to rank them. So let me do, I don't want capital A, I want little a, right. And what we have there is the ranks of the numbers, so that 1 is supposed to be the lowest number now. Well, we'll see what happens when I apply the next bit to it. I want to actually save that. I'm still a little bit worried about how it thinks it's going to rank them like that. 1, 6 should be the biggest number. It doesn't look that way. Has A got itself modified somewhere or other? No, okay. Let's try it the other way. Did warn you, I'm a complete novice, but that actually looks to be more or less sensible. That is ranking the one from... The second one on the right is the biggest number, and so it's number 1. And then so on. And if I now... APL indexing. You're used to indexing in C++ and C and so on, which you just have one thing to index. APL believes indexes should be much more than that. So I'm going to save that answer to start with by having my variable b and assigning to it the result of that, and look at my B, and you see it's the same thing. It's all right. But now I want to use that to reorder A. Now I have to remember if I got this one right. A, square bracket, index, B, there we are, ranked in order for you. Because as far as APL is concerned, that indexing system is absolutely fine. In fact, you can have multi-dimensional indices, and well, I won't go too far into that at the moment. But now the question is, actually, could I do all this together? So let's see if I can actually get this working. It's very, very easy when you're sitting in your bedroom typing away, and not so easy when you've got an audience in front of you watching you make a fool of yourself. Right. I want to start with having A storing the same A, it doesn't matter, overwrite it. Not that, storing 6 numbers chosen at random from, I'm fed up with 49, let's have something else. Oh, not that. Oh, getting worse, isn't it? Right, there we are. Let's have 56. Right. So that would give you a value A, but actually I want to actually apply the ranking thing to it. So I will put that in front. Whoops. APL thinks I'm up there when I'm actually down here. So let's... So the result of that would be ranking the contents of A, which we have made to be 6 numbers chosen at random from 56. However, we actually want to use that to index A. Oops, actually, the tooltips on this are actually quite useful. It's a very nice implementation. You know, if you want to know what the contents of the thing is, just hover your pointer over it. And after a second or so, it decides you want to see the contents and it shows them to you. Right, let's see what we get now as the answer to this. All right. Now, to C++ programmers and so on, that looks like a very dangerous expression because I have reused a variable and order of implementation and all the rest of it. But absolutely no problem to APL because it's strictly right to left. So it can't use a square bracket at the moment, so it leaves that aside. That's a compound operator, if you know. It's a compound function. I broke off before, didn't I? APL's functions are all the things that take 1 or 2 object arguments. It reserves the name operator, which we're coming to in a moment. An operator is something that has a function as one of its parameters. Right, so there we have a very simple little program to do your lottery entry. Just one simple line there, and all you need to do is to change those 2 numbers according to how many numbers you need and so on. Okay, any questions? Okay. Let's take another little simple feature. I'm sorry, I use single letter variables simply because in this context, they're quick to type. And I want some text. So let's have some text. Okay, just check, see really is that. Now then, somebody comes along to you and says, how many E's are there in that? Well, the first thing is that is an array of characters. Remember I said they're either scalars or arrays. Characters will be, text is an array of characters. So I can write I wanted E, didn't I? So let's have an E equals C. C is an array. E will in actual fact be a scalar because it's only one character. So the first thing I get is it's taken every character in my text and said, this is an E. And it gets you a Boolean answer. No or yes. But actually, I didn't want that. I wanted to know how many. Well, that's okay. Because now we're going to use a genuine operator. Interesting, because it was something which you used earlier as a function. I'm going to have a plus sign and then that. Now, because there's a plus sign on the left of the solidus, that means the solidus is no longer a function name. It's an operator name. And it's an interesting operator because it basically says what you have on your right-hand side, which is going to be E quote equals C. What you've got there, take that array and put a plus sign between every one of the numbers in it. It distributes a plus sign across all the elements of the array. And so now when there you are, there were 6 E's. Does this begin to show you some of the power of array thinking, noticing that if you wanted to write that same thing in your favorite language, you would probably have at least one loop involved. And loops are very, very rare in APL. APL does have a looping facility, but they are very rare because most of the time you shove the looping under the covers. Now, let's try something slightly different. I want an array. I want a matrix. Let's have what size matrix should we have? Let's have a matrix of 5 things of 3. So it's a 5 by 3 matrix. And then I put the Greek letter rho in. Easy to remember, it's Control R. Rho is called shape. And what it's, in this context, because it's got something on its left, it says the thing on the right is going to be reshaped to that. And I just want to have the numbers 1 to 15. So next one, Control I gives me iota. And iota says, yeah, well, I'll do it separately in a moment, but let's just put that one in. There is my array, 5 rows of 3 filled with the numbers 1 to 15. That's because the iota command simply gives you the numbers in ascending order, however many. Of course, you can modify them if I wanted the even numbers to times iota 8, shall we say. So the first 8 even numbers. Is that a useful technique? Actually, when I first came across iota, I said, And then I began to realize how powerful it was in the use of indexing. That if I want to take a large matrix or higher order array and access perhaps all the even columns, then I can use 2 times iota whatever to, in an index operator, to select out the even columns, the even things with an even index. So iota is actually quite a useful tool. How am I doing for time?
I think we are going to wrap it up.
Sorry?
We're wrapping it up.
Right, okay. I hope that has given you a little bit. And can I just, as a wrap-up, say, recommend going away, the dialogue APL I'm using is entirely free. It is a full-weight commercial version, but if a non-commercial use, they will give it to you. They not only give it to you, but they give you superb help desk, documentation. Yes, you're not paying anything and they will help you. They really will. I was actually staggered at the level of help that I got. And among the documentation, there's an introduction to using APL, and it really is just exploring a little bit, because it will open your eyes to other things that can be done in programming, and perhaps then you will want an array library, a decent array library in your language of your choice. Thank you for your attention.